Good day, dear colleagues, friends, and those who are involved in the satellite communications industry. My name is Andrei Kyrilovich, and I'm the Director of Integration Projects in RSCC, Russian Satellite Communications Company, a global geo-satellite communications operator. Throughout 2020 and now 2021, we have been developing an online project initiated by Intersputnik Operations Committee called The Voice of Satellite Industry. This is a series of online video interviews with the leading experts in satcom and telecom industries on the hot topics related to the use of satellite in all spheres of human life and economy. Hereby we present our next episode. Today in telecom world, it is quite difficult to find any other topic hotter than 5G. This is a new religion, next multi-billion or even multi-trillion dollars opportunity. A network of networks with multiple slices, access technologies, and multiple opportunities for digital future. Satellite will be a vital part of this ecosystem for sure. But before entering the 5G future, it is essential to understand the basics. What is happening now in terms of marriage between satellite and mobile industry? The rules of the game come first. So for any technology applications, a set of standards must be identified. So I'm glad to welcome my today's guest and speaker, Mr. Sasha Sirotkin, Vice Chairman of RAN3 Working Group in 3GPP, an organization which sets standards for the mobile industry. Sasha has got 20 years of experience in wireless communications, system architecture, standardization, and research. His 3GPP RAN3 Working Group is responsible for radio access network architecture. So good day, Sasha. Thank you very much for joining us today.
Hello, thank you for having me.
Okay, and now let's start with the questions. And my first question is as follows. As I said earlier, nowadays, everybody understands that the future of telecom industry is in 5G networks. But what is so unique in the fifth generation of mobile network compared to the previous ones that makes it so promising?
So, in my view, 5G is not so much a revolution, but rather an evolution of 4G. That means that, in my opinion, again, there is no single killer feature which makes it unique, but rather a combination of different improvements, enhancements that sets aside 5G compared to other technologies, for example, LTE. There are perhaps two biggest new features which may need to be called out. Those are support for millimeter wave frequency and low latency. But besides those, there are a multitude of numerous improvements at different layers of the network, from the physical layer to the protocol stack, to the RAN architecture and the core network. Just to give a few examples, for example, in the physical layer, 5G physical layer has been designed with so-called scalable numerology in mind, with variable subcarrier spacing, which makes it easier to adopt it for different frequency ranges and bandwidth. It also supports mini slot-based scheduling for improved latency, wider bandwidth, massive MIMO. It is also designed with the forward compatibility in mind, thanks to so-called blank resources, which was one of the issues in LTE. It is more power efficient, as there are much less always-on signals, which were, again, a problem identified in LTE. It also supports LDPC and polar coding. And again, there are many, many other improvements in the physical layer. In the protocol stack, there is, of course, the inactive state, which improves both latency, control plane latency, and power efficiency, more flexible QoS, and many other improvements, too many to list here. In the radio access network architecture, again, the architecture is much more flexible. There are a number of split options which allow 5G RAN to be deployed in many different scenarios with many different constraints in terms of backhaul latency and throughput. On the core network, many improvements, the biggest of which is perhaps virtualization, which may be of less relevance to your audience, but still worth mentioning. So in summary, I would say that 5G is unique due to the breadth of many different use cases and scenarios it can be support. I find it useful to think of 5G standard as a toolbox, which anybody can use to build a system which suits their needs. That, however, comes at a cost, because 5G is also, incidentally, more complex than 4G, but no pain, no gain. So that's, in a nutshell, I would say the main differences of 5G compared to LTE.
Okay, Sasha, thank you very much. So speaking about one of the tools, What is the role of satellite in 5G ecosystem? Is there any room for satellite channels there? And what use cases are considered for satellite in the framework of 5G network architecture?
So obviously there is room for satellite, and satellite is considered an integral part of 5G. Maybe not from the first 5G release, which was release 15, but support for 5G access is being added right now. So traditionally, in the past, satellite has been used primarily for backhaul. And that did not require any standards changes because 3GPP backhaul is similar, pretty much only needs IP transport, which satellite can provide. Starting from release 17, we are adding support for satellite as access. Prior to that, we had a number of studies to study satellite channel models and various solutions. This has been completed in release 16. And now in release 17, which is an ongoing release, there is a normative work to specify satellite access in 5G. There are actually two tracks for that work. One is mobile broadband, and another one is IoT. IoT is being defined a little bit later. So IoT is currently in the study item phase, but most of the features, most of the support that we define currently for satellite mobile broadband can and most likely will be reused for IoT. So in terms of use cases, we already agree to support all sorts of satellite or similar devices, that is LEO, GEO, hubs, high altitude platform stations, and air to ground. We assume terminals with GNSS capabilities, which makes certain features simpler. In terms of network architecture, we support transparent payload, that is bent pipe in other terminology, so that the base station is actually located on the ground. And in terms of handheld devices, so handheld devices in FR1 frequency range are supported, and VSAT devices with external antennas will be supported in FR2 frequency range. Again, it is important to emphasize that the work is ongoing. So by the end of release 17, we will have all the details. But we can, at least in terms of scenarios, to be supported, features to be defined, and issues to be resolved, we already know what is happening.
Okay, thank you very much. And the next question is actually, I think, the most important for me, because I was waiting to ask for it. So why for satellite it is so important to be embedded into a new generation of mobile network at the standard layer as a part of non-terrestrial network, and why the satellite was not included in the standards of previous generations?
So I will perhaps start from the second part of your question. As we often say in 3GPP, our work is contribution driven. That is, any member can drive any agenda, any technology, any feature that that member desires to be included in the standard. But for that, a company or an ecosystem has to be a 3GPP member. 3GPP is an open organization. Anyone can join, anyone can take part in our standards work and drive whatever technologies, whatever features, whatever agenda he or she desires. And so in the past, that was not so much the case for satellite companies. But what we are seeing now with the advent of 5G is that many satellite companies, operators, and vendors joined 3GPP, became 3GPP members, now take active part in our standardization work. So why now? Because satellite ecosystem decided to join 3GPP and to drive this technology into the standard. Why is it important? I think in general, standards are important because they allow the primary reason, I would say, is because standards-based technologies typically enjoy economies of scale. So obviously anything can be implemented in proprietary fashion and it will work, sometimes maybe even in some cases even more efficiently. But if you want to enjoy economies of scale, drive down costs, then standards is the way to go. And I would imagine that this is one of the reasons that the satellite ecosystem joined 3GPP and decided to take part in this activity. Besides that, besides the economies of scale, there is perhaps another technical advantage, is that once satellite access is fully integrated into 5G system, there will be service continuity supported between satellite access and the terrestrial networks, which I would say is important, at least in some scenarios and some use cases. So that's my view, but that's of course only my view. I cannot speak for the whole satellite industry.
Okay, thank you very much for your opinion. And the next question is a bit from a different angle. The major disadvantage of satellite communications besides costs is the latency. Could you please explain what changes have been introduced in the mobile network standard to support satellite channels as an integral part of the 5G network?
Good question. So indeed, latency is one of the main issues to be addressed in the work which is currently ongoing. And as I mentioned, the work is ongoing, so I cannot provide all the answers, but I can describe what is being done as we speak. Besides latency, 5G actually is designed in such a way that it is sufficiently flexible to accommodate a satellite. So in terms of the work that we are currently doing, we're looking into, from the system perspective, we're looking into feeder link switch event, which is different. We don't have such events in a regular terrestrial network. So that is something that needs to be addressed. Also, the situation here is a little bit different because in terms of mobility, in the regular terrestrial network, the handset is assumed to be mobile, but the network is stationary, which is not necessarily the case in satellite, at least for LEO. So mobility will have to be addressed. And besides that, indeed, most of the work will be revolving around latency. One of the issues, latency, is HARQ, hybrid ARQ, which is a mandatory feature in 5G system, and HARQ requires round-trip time of milliseconds, which is not always possible. So one of the solutions, which most likely will be defined, is the capability for the network when it cannot be supported if the round-trip time is too large. Besides that, obviously frequency synchronization will have to be addressed. Many different timers and sequence numbers will have to be extended because when those were designed in 5G, simply the timer range and sequence number ranges were not large enough, but this is a relatively simple enhancement. There will be the same applies to peerage. For example, a response window duration is likely going to be extended. Those, I would say, are the mandatory features that we have to address. As I said, they are not radical, they're not major. Beyond those, we may add a number of enhancements and improvements to make a satellite work better. For example, one of the issues is mobility. And mobility is also incidentally affected by latency because normally in 5G networks and in LTE, mobility is controlled by the network. Because the latency is higher, the information that the network has to make mobility decisions may not necessarily be up to date. So thankfully, in 5G, we support so-called conditional handover, which gives more autonomy to UE to make mobility decisions. And so I would assume, actually, I'm pretty sure that a conditional handover will be reused heavily in satellite networks to alleviate the issue of latency when it applies to mobility. So those are, I would say, the features that we need to, not so much features actually, but relatively not major enhancements and improvements that we need to make so that 5G is suitable for satellite access.
Okay, thank you. This was very informative and detailed answer. And my final question is actually on IoT. So you mentioned IoT is one of the use cases, and it's one of the main promising technology for 5G. It will be the massive and ubiquitous use of IoT applications, devices, and solutions. And ubiquity is impossible without satellites. So what is planned in this regard in 5G to support satellite IoT applications?
Thank you. Very good question indeed. So indeed, IoT is one of the main markets for 5G, not because mobile broadband is not important, but because the ecosystem is obviously looking to expand into new markets, and IoT is one of those. Currently, as I mentioned previously, the work on satellite access in 3GPP is being done in two tracks. The first one is currently in release 17 in a work item phase. That is, we are currently working on normative specifications, which will be completed in release 17 to support mobile broadband for satellite. IoT for satellite is currently in a study item phase. That means that the normative work will most likely happen in release 18. But it will take into account and will be most likely largely based on what we define currently for mobile broadband. So on the high level for that work, we will look into NB-IoT and MTC technologies, which are actually LT based, not NR. And we will consider all the enhancements and improvements that we are going to make for NR, new radio to support satellite, and apply those enhancements and improvements to narrowband IoT and MTC. Other than that, there is not much I can say at the moment because the work is still early days. It is ongoing and it is ongoing in the study item phase. But basically, we will look into the same scenarios that I mentioned in terms of LEO, GEO hubs and other devices to be supported. The same issues related to latency, random access, mobility, HARC, timers, different offsets, timing advance. So all those features, I assume that we address in release 17 will be relatively easily applied in release 18 for NB-IoT over satellite. So that's all I can say at the moment, because the work on IoT for satellite is still very much ongoing in the early days and will be completed most likely in release 18.
Okay, thank you, Sasha. Thank you very much for your time. It was really interesting interviews, and I really enjoyed the answers. It's clarified a few things for me, and I hope for our audience. And I think it was very interesting for our audience as well, because we have a lot of satellite operators, satellite service providers as our viewers. And in case if you have any, so dear viewers, dear viewers of their Voice of the Satellite Industry, if you have any further questions regarding the work of 3GPP and standardization, please contact Sasha or 3GPP website. So his contacts will be in below in the text below our video interview. Thank you, Sasha. Thank you very much for your time.
Thank you for having me. And perhaps to conclude, I will mention to your audience that I'm very happy that the satellite industry, along with many other verticals, such as automotive and industrial, joined 3GPP and now take active part in our work. Thank you.
Thank you.
Have a good day.
Bye.